Hi everyone, in this video we are going to solve O-Levels Additional Mathematics Paper 1 in a session May-June 2021 Paper 1-2. So let's begin with the first question. So in question 1 we need to write this expression in the form p power a, q power b, r power c, where a, b, c are constants. Okay, so let me simplify this. So first we can see that PQR power minus 2 and this P square R power minus 1. We can do a reciprocal. We have R power 1 by 3 over Q power 3 times, we can do a reciprocal P square R and its power is 1 now, and PQR and its power is 2, right? In order to make the positive powers, we do the reciprocal. Now we have p square and r power 1 and power 1 by 3. So we have 1 plus 1 by 3. When the bases are same, we can add the powers. So we have 4 by 3 over, we have p square, we have q square and q3. So 3 plus 2 is 5 and we have r square, right? Okay, let's do a further simplification. So we have p power 2 minus 2, q power minus 5, r power 4 by 3 minus 2. So here we have p power 0, q power minus 5, and r power 4 by 3 minus 2 is minus 2 by 3. Minus 2 by 3. Right, so we have written this expression in this form where a is 0, b is minus 5 and the c is minus 2 by 3. Now for question number 2, in a part, on the axis sketch the graph of the function stating the intercepts with the coordinate axis. Okay, so we have given the absolute value function. To graph out this function, if I consider it as y equals to 4 minus 3x without absolute, right? Let me find out the intercept of it from this function. So first we can find the x-intercept by putting y equals to 0. So we have in the y is 0. So minus 3x plus 4 equals to 0, and the x value would be 4 by 3. Right, so what is 4 by 3? We have 4 divides 3 is 1.3 basically. So we have x-intercept 1.3. Okay, now let me find the y-intercept. For y-intercept, we need to put x is equals to 0. So y is equals to 4. So we got the y-intercept equals to 4. Okay, so let me find the scale. So there's 1, 2, 3, 4, 5, 6, 7, and from here 1, 2, 3, 4, 5, 6, 7, and from this point we have 1, 2, 3, and 4, and the bottom one we have 1, 2, 3, and 4. Okay, so we have y is 4, so if we can say we have 2, 4, 6, and you have minus 2, minus 4, minus 6, and this is 1, 2, 3, 4, 5, 6, 7, and here we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and minus 7. So the x-intercept is 1.3. Here it is 1.3 and the y-intercept is 4. So we have 4. Okay, so we need to connect these 2 points to get the one part of this absolute value function, and we know that the absolute value function is always positive. So for the second part of this function, we can take any point. Let's say when x is equals to 3, what is y? So we can find y equals to 4 minus 3 times 3. So y is the absolute value function, right? So y is equals to 4 minus 9, and y is equals to absolute of minus 5, and that is equals to positive 5, right? So when x is equals to 3, the y value is positive 5. So this is 3, and we have 6, and in the middle of 4 and 5 we have 4 and 6 we have 5, this point. So we can connect this part as well. So this is the graph of y equals to absolute of 4 minus 3x, and the intercepts are 4 by 3 and positive 4. Okay, now moving to the b part, solve the inequality. How can we solve this inequality? So we can do it by, we have absolute of 4 minus 3x is greater than equals to 7. Okay, so when we, this absolute means positive and a negative. So we have two answers. So we can say 4 minus 3x is greater than equals to plus minus 7, right? So it means 4 minus 3x is greater than equals to positive 7, and we have 4 minus 3x is greater than equals to negative of 7. Right, now let me solve both of them. So minus 3x is greater than equals to 7 minus 4, right? And 7 minus 4 is 3. So minus 3x is greater than equals to 3, and dividing both sides by negative 3. So whenever we are dividing or multiplying with a negative number, we need to reverse the inequality. So x is less than equals to minus 1, right? From here, minus 3x is greater than equals to minus 7 minus 4. Minus 3x is greater than equals to minus 11. We can cancel the negative sign. And 3x is greater than equals to 11, and x is greater than equals to 11 by 3. So we have two answers. X is less than equals to minus 1, and x is greater than equals to 11 by 3. Question number 3. The diagram shows the quadrilateral OABC. OABC. This is a quadrilateral such that O to A is A, O to B is B, and O to C is C. The lines OB and AC intersect at P such that AP is 3 and PC is 2. So AP is in the ratio of 3 and PC is in the ratio of 2, and the total 3 plus 2 is 5. So this is 3 by 5 of AC, and this A to P, and P to C is 2 by 5 of AC. Right. In the first part, find OP in terms of A and C. OP. Okay, so OP follows a path of O to A and A to P. OP is equals to OA plus AP. So OA is A and AP is 3 by 5 of AC. Right. Now let me find the value for AC. So how can we find AC? So A to C is equals to A to O and O to C. AO plus OC. So AO is negative A, positive C. So this is AC. So let me substitute it over here. So A plus 3 by 5 of C minus A. So this is equals to A plus 3 by 5 C minus 3 by 5 of A, right? Okay, so we have 1 minus 3 by 5. This is 2 by 5. So we have 2 by 5 of A plus 3 by 5 of C. This is OP. Right. Now for part B, given also that OP and ratio PB is 2 ratio 3. Okay. OP and PB. So where is OP and PB? So OP and PB, this is in the ratio of 2 ratio 3. So this is again 2 by 5 of OB, and this is 3 by 5 of OB, and OB is, we know that it's B, just a vector B. Okay, now show that 2b is equals to 3c plus 2a. Okay, so OP. So from this information we know that OP is 2 by 5 of OB, that is 2 by 5 of vector B. This is OP. So this is OP and this is also OP. So we can compare both of them. So 2 by 5 of B is equals to 2 by 5 of A plus 3 by 5 of C. Right. So we can cancel the 5 that is in the denominator. So we are just left with 2b is equals to 2a plus 3c, or 2b is equals to 3c plus 2a. So we have showed this expression. Question number 4. A curve is such that its second derivative is this. The curve has a gradient 4 at the point this. Find the equation of the curve. Okay, so we have given the second derivative. We need to find the value for y. Okay, so first we need to integrate twice to get the value for y, and that is the equation for the curve. So d2y over dx square with respect to dx we are doing. So this is 3x plus 2 power minus 1 by 3 into dx. Okay, so here we need to apply the power rule of integration, and it's 3x plus 2 with respect to x, its derivative is 3. So we can multiply and divide by 3 to complete its derivative. And now we have dy over dx is equals to 3 times, 1 by 3 times. This is 1 by 3 times 3x plus 2. The power is minus 1 by 3 plus 1 over minus 1 by 3 plus 1 plus some constant, right? So minus 1 by 3 plus 1, minus 1 divides 3 plus 1 is 2 by 3. Okay, so we have dy over dx is equals to 1 by 3. 2 by 3 means 3 by 2, and 3x plus 2 is 2 by 3 plus some constant, right? So we can cancel the 3. We are just left with 1 by 2. So dy over dx is equals to 3x plus 2 power 2 by 3 over 2 plus some constant, right? And in the question we have given the information that the gradient is 4 at this point. So we can use that to get the value for C. So the gradient is 4 when the x value is 2. So we have 3 times 2 plus 2 divides 2, and its power is 2 by 3 plus some constant. Okay, so 3 times 2 is 6, and 6 plus 2 is 8. And we know that 2 cube is equals to 8, and cube is cancelled, and then 2 square is 4, and 4 divides 2 is 2, and 4 minus 2 is 2. So the C value is 2. Okay, now let's substitute the C value to get the gradient. So dy over dx is equals to 1 by 2 3x plus 2 power 2 by 3 and then plus 2. Now we need to find the equation of curve. We need to integrate one more time. So take the integration on both sides with respect to dx. So we got y over here, 1 by 2 is outside, and integration of this term 3x plus 2 power 2 by 3 dx. Again, we can apply the power rule of integration when its derivative is complete, and its derivative is 3. So we can multiply and divide by 3, and plus integration 2 is outside and dx, right? So y would be equals to 1 out of 6, and this is 3x plus 2 power 2 by 3 plus 1 over 2 by 3 plus 1 plus 2 times x plus some constant. Let's say C star is a constant, right? 2 by 3 plus 1 is 2 by 3 plus 1 is 5 by 3. Okay, so y is equals to 1 by 6. 5 by 3 changes to 3 by 5. 3x plus 2, 5 by 3 plus 2x plus c star. 3 times 1 is 3, 3 times 2 is 6, and 2 times 5 is 10. So y equals to 3x plus 2. The whole power is 5 by 3 and dividing by 10 plus 2x plus c star. Okay, we can find the c star, the constant, by using the condition. We have given the point that is 2 and 6.2, right? So we can use this point to get the value for the constant. X is 2 and y is 6.2. So we have 6.2 over here, and 3 times 2 plus 2, and the power is 5 by 3 over 10 plus 2 times 2 plus c star. Okay, so we can do 3 times 2 is 6, 6 plus 2 is 8, and 2 cube is 8, cube is cancelled with cube, and 2 power 5 is 32 and dividing by 10. So here we have 6.2 equals to 32 by 10 plus 4 plus c star. Okay, so to get the value for c star, we can do 6.2 minus 32 by 10 minus 4, we will get c star. Okay, so we have 6.2 minus, okay, 32 divides 10 is 3.2. Okay, 6.2 minus 3.2 minus 4 minus 1. So the c value, c star, is negative of 1, and the equation of curve, if I can write here, y is equals to 3x plus 2 power 5 by 3 divides 10 plus 2x minus 1. So this is the equation of the curve. Question number 5, in A part, given that log AP plus log A5 minus log A4 is log A20, find the value of P. Okay, so as you can see, in all the logs, the base is same, A. So we can take log A, log base A, and these two logs are add, and this is subtract. So we can multiply and divide. So P times 5 because P plus 5, and divide by 4 because it is in with the subtraction sign. So this is log A20. Okay, so we have a same log on both sides. We can cancel the log A and log A. We are just left with P times 5 divides 4 equals to 20. And to get the value for P, we can do 20 times 4 by 5. Okay, so 20 times 4 divide 5 is 16. So the P value is 16. Right. Now for the B part, solve the equation. Okay. So if I can write it, 3 power 2x times 3 plus 8, 3 power x minus 3 equals to 0. It is some kind of quadratic equation. We can factorize it. To solve this equation, basically we need to find the value for x. So if I have 3 is a coefficient of 2x, 3 power 2x plus 8 is a coefficient of 3 power x minus 3 is a constant equals to 0, right? So let me find the factors. We can break the midterm. As you can see, 3 times 3 is 9. 3 times minus 3 is equals to 9. And 1 times minus 9 is minus 9. And 9 minus 1 is equals to 8. We can break the midterm by using 9 and minus 1. So we have 3 power 2x and plus 9 3 power x minus 1 3 power x minus 3 equals to 0. We can take 3 common and 3 power x common. We are left with 3 power x plus 3. Taking minus 1 common, 3 power x plus 3 equals to 0. Now we have two factors. The first is 3 power x minus 1, and the other is 3 power x plus 3 equals to 0. To solve for x, we need to put both the factors separately equals to 0. Let me put this factor first equals to 0. So we have 3 power x minus 1 equals to 0. So we have 3 power x equals to 1. 3 power x is equals to 1 by 3, or we can say 3 power x is equals to 3 power minus 1. When the bases are same, we can compare the powers, so x is equals to minus 1. So this is a value of x we got. Now let me do for the second one. We have 3 power x plus 3 equals to 0. 3 power x is equals to negative of 3, and to solve for x, we need to take log on both sides, right? So x log 3 is equals to log of minus 3. So log of negative number is infinity. So here x value is infinite, so the only x value is negative 1, right? Now for the C part, solve the equation. So here we need to use a change of base formula. So the change of base formula in the logarithm is, when we have log base BA, we can use log CA over log CB, right? So we have log 2y and log y2. So this is okay, we can change this one. So how can we change this one? We can use log y2. We can say log 2 over log y, and the base I would like to select is 2. So log 2 is 1, and we have just log 2y. Yes, so it is 1 over log 2y. So let me substitute it here. So 4, and this is 1 over log 2y plus log 2y equals to 4, right? Let me take the LCM. So we have 4 plus log base 2y whole square divides log base 2y equals to 4, right? And now we have 4 plus log base 2y whole square, and this is equals to 4 log 2y, right? Now let me shift this term on the other side. So log base 2y whole square minus 4 log base 2y plus 4 is equals to 0. So this is a plus b whole square formula basically. This is log base 2y whole square minus 2 times a value log base 2y times 2 and then plus 2 square. So this is equals to log base 2y minus 2 whole square equals to 0, right? So if whole square is equals to 0, we can, taking the square root on both sides, square root of 0 is again 0. We are just left with log base 2y minus 2 equals to 0. Log base 2y is equals to 2, and the y value is 2 power 2, that is equals to 4. So we got y equals to 4. Question number 6. Do not use a calculator in this question. A curve has an equation this. In A part, find the x coordinate of the stationary point on the curve, giving your answer in the form of a plus b square root of 5, where a and b are integers. For stationary point, we need to find the gradient of the curve and put it equals to 0. At stationary point, the gradient is 0. And what is gradient? Gradient is the derivative, the first derivative. So we have given the y, we need to find dy over dx and put it equals to 0. So this is 3 plus square root of 5, and this is 2x minus 8 square root of 5, it's 1 and 0. Okay, so for stationary points, what we need to do dy over dx equals to 0 and solving for the value for x. So we have 3, 2 is outside, plus square root of 5 into x minus 8 square root of 5 is equals to 0. This means 2 times, okay, 2 is outside, 3 plus square root of 5 x equals to 8 square root of 5, and the value of x is 8 square root of 5 divides 2 times 3 plus square root of 5. 2 times 1 is 2, 2 times 4 is 8, and we have x is equals to 4 square root of 5 over 3 plus square root of 5. Okay, so we need to find the answer in terms of a plus b square root of 5. So we need to multiply and divide with the conjugate of the denominator. So what is a conjugate for the denominator? So this is 3 minus square root of 5 over 3 minus square root of 5. So the x value is 4 square root of 5 is going to multiply with 3 minus square root of 5 over, we have 3 square minus square root of 5 square, right? So we have 4 times 3 is 12 square root of 5, and 4 negative 5, 4 times 5 is 20 over 3 square is 9 minus 5. So if I can take 4 common from the numerator, we have 3 square root of 5 minus 5. In the denominator, 9 minus 5 is also 4. We can cancel it out. So x would be equals to 3 square root of 5 minus 5. So we got the x value in terms of a plus b square root of 5. A value is minus 5 and the b value is 3. Now the b part, hence find the y coordinate of this stationary point, giving your answer in the form of c square root 5, where c is an integer. Okay, now we need to find the y coordinate of the stationary point. For this we need to use the x coordinate and put it into the equation, into the curve. We will get the y coordinate. So the x coordinate we got is 5 square root of, x coordinate is 3 square root of 5 minus 5, right? We can substitute that x coordinate into the curve to get the y coordinate of the stationary point. And the curve is y equals to 3 plus square root of 5 x square minus 8 square root of 5x plus 60. So y equals to 3 plus square root of 5 into x square minus 8 square root of 5 into x and positive of 60. Now let me substitute the x value to get the y coordinate. So y is equals to 3 plus square root of 5, 3 square root of 5 minus 5 whole square minus 8 square root of 5 into 3 square root of 5 minus 5 and then plus 60. Here we can open the square formula. So y is equals to 3 plus square root of 5 is as it is. So we have 3 square root of 5 whole square. 3 square is 9 and 9 times 5 is 45. Plus 5 square is 25 minus 2ab. So minus 2 times 3 times 5, negative 30 square root of 5. Okay, and this is as it is, minus 8 square root of 5 is going to multiply with 3 square root of 5 minus 5 and then plus 60. In the next step I will multiply. So now y is equals to 3 plus square root of 5 into 45 plus 25 is 70. 70 minus 30 square root of 5. And here we have 3 times 8, 24, and 5 square root of 5 square is just 5. So 120 minus 120, and then minus times minus is plus. 8 times 5 is 40 square root of 5 and then plus 60. Right. So now y is equals to 3 times 70 is 210. Minus 3 times 30 is 90 square root of 5 plus 70 square root of 5 and minus 30 times 5, 150, minus 120 plus 40 square root of 5 plus 60. Okay, so y would be, so first let me solve the constant terms. So the constant terms, you can see we have 210 minus 150 minus 120 plus 60. So the constant terms are 0. Now the terms with the square root of 5, we have negative of 90, positive 70 and positive 40. So we have 20 square root of 5 is the answer. And this 20 is the value for C that we have given at the top. Question number 7 in A part, a 6-character password is to be made from the following 8 characters. So we have digits 1, 3, 5, 8, 9 and symbols asterisk, dollar and hash. No character may be used more than once in a password. So it means it is a permutation question. And in permutation, order matters, right? Find the number of different passwords that can be chosen if there is no restriction. Okay, so if there is no restriction for 6 character, we have 1, 2, 3, 4, 5, 6. Since there is no restriction, so for the first digit or first character, we have how many options? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 options, and then 7 options, then 6, then 5, then 4, and then 3 options. So we can multiply to get the number of passwords. 8 times 7 times 6 times 5 times 4 times 3. So 20,160. 20160 passwords we can make if there is no restriction. Now for the second part, the password starts with a digit and finishes with a digit. Okay, so again a 6-character 1, 2, 3, 4, 5, 6. So starting with a digit and finishes with a digit. So 1, 2, 3, 4, 5. So we have 5 digits. So for first we have 5 options. If we use one of it, we have 4 options for the last, right? So we use the 2 of them, and 1, 2, 3, 4, 5, 6 are left, and then 5, and then 4, and then 3. So we can multiply and we will get 5 times 6 times 5 times 4 times 3 times 4. So 7,200 passwords we can make when it starts and finishes on the digit. Okay, now for the third part, the password start with 3 symbols. Okay, 6-character 1, 2, 3, 4, 5, 6. So it must start with 3 characters, 3 symbols. It can be asterisk, it can be this, or it can be this. Okay, so for the first we have 3 options because we have 3 symbols, and when we use one symbol we have 2 options here and we have 1 option here, and we have 5 digits, and then we have 4 digits, and then 3 digits. Okay, so multiply. We have 3 times 2 times 1 times 5 times 4 times 3. 360 passwords we can make when the password starts with 3 symbols. Okay. Now for part B, the number of combinations of 5 objects selected from n objects. So NC5 is 6 times the number of combination of 4 objects selected from n minus 1 objects. Find the value of n. Okay, so we need to open this formula. So its formula is NCR is basically equals to n factorial over r factorial into n minus r factorial, right? So let me open that formula here. So we have n factorial over 5 factorial, n minus 5 factorial. We have 6 times n minus 1 factorial over 4 factorial, n minus 1 and minus 4 factorial, right? So here we can open n factorial as n into n minus 1 whole factorial over 5 times 4 factorial and n minus 5 factorial. This is 6 times n minus 1 factorial over 4 factorial and n minus 5 factorial. Let me cancel the like ones. N minus 5 factorial, 4 factorials, n minus 1 factorial. We are left with n by 5 is equals to 6. And the value of n would be 5 times 6. This is equals to 30. So n is equals to 30. Question number 8, the variables x and y are such that y equals to a x power b, where a and b are constants. When log y is plotted along against log x, a straight line graph passing through the points this and this is obtained. So it is a straight line and we have log y is plotted against log x. It means we need to take a log on both sides for this equation. So we have log y is equals to log of a x power b. So this is log of y and this is equals to log of a plus log of x power b. So again log y is equals to log a plus b log of x, or we can say log y is equals to b log of x plus log of a. Okay, so we know that the equation of straight line in slope intercept form is y is equals to mx plus b, right? So here m is the slope, so the slope value is b in this case, and the b is a constant value, that is log of a, right? So we need to find the value for a and the value of b in the a part. So first the b is the slope, so we have given the 2 points, we can find the value for b. So b is y2 minus y1 over x2 minus x1. So b would be 4.37 minus 0.57 over x2 minus x1 is 5.36 minus 0.61. Okay, so 4.37 minus 0.57 and this is equals to 3.8 over 5.36 minus 0.61. This is 4.75 and 3.8 divide 4.75, we have 0.8 is the value for b. So b is 0.8. Now we need to find the value for log of a. So this log of a is the y-intercept in this case. So we can find the y-intercept by using any of the point. So this is log of a. So if we use this point, the first point, that is 0.61 and 0.57. So since the constant is log a, this is the y-intercept, right? So this value is representing as log x and this value is representing as log y, right? So let me substitute the values. Log y is 0.57 plus equals to 0.8. Log x is 0.61 plus log of a. Okay, so 0.8 times 0.61 and then 0.57, subtract answer, we have the log of a value. So log of a is 0.082, and to get the value for a we can do 10 power 0.082. So 10 power answer is 1 point. So from here we can say a value is 1.21 and the b value is 0.8. Okay, now for the second part, using your values of a and b, find in b the value of y when x is equals to 3. Okay, so we have an equation y is equals to a 1.21 and x power b 0.8. We need to find y when x is 3. So y is equals to 1.21, x is 3 and 0.8. So that's easy. 3 power 0.8 and times by 1.21. So we have 2.91. Yes, so y is 2.91. Now for the C part, the value of x when y is 3. Okay. Now y is 3, we can find the x, 1.21, x power is 0.8. So 3 divides 1.21 equals to x power 0.8. 3 divides 1.21 is 2.48, or we can say 2.5. 2.5 is equals to x power 0.8. Okay, and to solve for x, what we need to do, we can take the power 1 over 0.8 on both sides, 1 over 0.8, right? We can get x value. So this term, power 1 divides 0.8, and this is 3.11. 3.11 is the answer for the x value. Question number 9, in A part, the first three terms of an arithmetic progression are -4, 8 and 20. Find the smallest number of terms and value we need to find for which the sum of this arithmetic progression is greater than 20,000. It means sum is greater than 2,000, sorry. Okay, so it is a arithmetic progression. So first we need to find the value for A. A is a first term, that is -4, and D is a common difference, 8 minus -4, that is equals to 8 plus 4, and that is equals to 12, and 20 minus 8 is also 12. So we need to use a sum of geometric progression formula, and that is equals to Sn is equals to n by 2 into 2a plus n minus 1 into d. This is a formula for the sum. Okay, so we need to find the n, dividing by 2. 2 times -4 plus d is 12 into n minus 1. This must be greater than 2000. We have given the sum is greater than 2000, right? So let me simplify. N by 2, we have -8 plus 12, n minus 12 is greater than 2000. So we have -8 minus 12 is -20. So n by 2 12n minus 20 is greater than 2000. Multiply n by 2 inside. So we have 2 times 6 is 12, 6n square minus 10n minus 2000 is greater than 0, right? So we can divide throughout by 2. 2 times 3 is 6, 2 times 5 is 10, and 2 times 1000 is 2000. Okay. Now we can find, this is a quadratic equation, we can find the value for n by using a quadratic formula. So the quadratic formula n is equals to negative of b is -5, plus minus square root b square is -5 square, minus 4 times a value times the c value, whole divided by 2 times of a value is 3. So here n equals to 5 plus minus square root. We have -4 times 3 times -1000, and add 25. So 12025 inside the square root, and then we are going to divide it by 2 times 3 is 6, right? Now we have two values for n, with a positive square root and with a negative square root. So let me do it one by one. 5 plus square root 12025, sorry, 5 plus square root 12025, and then divide by 6, and value is 19.1, and we have 5 minus square root 12025 divide 6 is negative. So we are not taking the negative because the number of terms never be negative, right? So we are not taking this negative term. We are just dealing with the positive term, and the value, the sum is greater than 0. So what value of n that is, and we know that the number of terms must be the natural numbers 1, 2, 3, 4, right? So it never be negative, and it is not in terms of the decimal, so n must be greater than 19.1. So we can say n is equals to 20. Now for part B, the 7th and 9th term of geometric progression is 27 and 243 respectively. Given that the geometric progression has a positive common ratio, find in the first part this common ratio. Okay, so for geometric progression we have a formula u bar n equals to a r n minus 1, right? So we have 7th term, we can say u7 is equals to 27. This is equals to a r power 6, and u9 is 243, and this is equals to a r power 8. So we can write it down as a r square, a r 6 times r square, right? And a r power 6 is 27. We can put that 27 here. So 243 equals to 27 r square, and 243 divides 27 is the value for r square. So 243 divides 27 is 9, and the value for r square, we can do the square root of 9, that is 3. So the common ratio is 3. It is positive common ratio, and 3 is positive. Now for the second part, the 30th term, giving your answer as a power of 3. So we need to find the 30th term. So u30 we need to find, that is equals to a r power 30 minus 1 is 29. So we know the r is 3. Now what is a? We need to find the value for a first. So to solve for a, we can use the value of r over here. So if I can say that 27 equals to a, r is 3 power 6. So we have 27 over 3 power 6 is equals to a. Okay, so 3 power 6 and 27 divide answer is 1 by 27. So a is 1 by 27. So just substitute the a value, that is 1 over 27, and this is 3 power 29. And 1 over 27 is basically 1 over 3 square, and we have 3 power 29, and we have 3 power 29 minus 3, and this is equals to 3 power 26. So the 30th term as a power of 3 is power 26, right? Now for the C part, explain why the geometric progression 1 sine theta, sine square theta, and so on, when the theta is between minus pi by 2 and plus pi by 2, where theta is in radian, has a sum of infinity. Okay, so it is a geometric progression, so it has a same common ratio. So we can say the common ratio is sine theta over 1, sine theta over 1, so the ratio is sine theta, right? Sine square theta over sine theta is again sine theta, right? Okay, and what is the range for the sine? The range of sine function is, it must lies between minus 1 and plus 1, right? So it's plus 1. Okay, and this, or we can say that absolute of sine theta is less than equals to 1, right? And this sign is r. So when the absolute of r is less than equals to 1, we have the sum as infinity. We use s infinity, that is equals to a over 1 minus r when absolute of r is less than equals to 1. So this is the only reason that this geometric progression has a sum to infinity. Question number 10 in A part, solve the equation for minus pi is less than alpha is less than pi, where alpha is in radian. Okay, alpha is the angle that is in radian. Okay, so we have sine alpha, and for the cosecant we have 1 over sine square alpha plus cos alpha, and this is 1 over cos square alpha equals to 0. Right, so we can cancel sine alpha with the sine alpha, cos alpha with the cos alpha, right? And what we are left with 1 over sine alpha plus 1 over cos alpha equals to 0. We can take the LCM. We have cos alpha plus sine alpha divide cos alpha into sine alpha equals to 0. Multiplying this with 0, we have 0. So cos alpha plus sine alpha we have equals to 0. Right. So from here we can say minus of cos alpha is equals to sine alpha, minus 1 is equals to sine alpha over cos alpha, and sine by cos we know is tangent of alpha. Okay, so from here we know that tan alpha is equals to minus 1. Now we need to check on which quadrant the tangent is negative. Let me draw the quadrants. Okay, so in the first quadrant all trigonometric ratios are positive, then sine is positive, then tangent is positive, and then cosine is positive, right? And in the first we have theta, and then we have pi minus theta, and then theta plus pi or pi plus theta, and 2 pi minus theta, right? So since we have an equation that tangent of alpha equals to minus 1, right? So tangent is negative in second quadrant and in fourth quadrant, because in first and third the tangent is positive. So we need to use the second and the fourth quadrant. Okay, so first we need to find the answer with the positive one, like tangent alpha equals to tan inverse of 1, and that is equals to pi by 4, 45. We can also double check. Tan inverse 1 is 45, that is pi by 4 in radian. Yes. So this is a value of alpha. So now the tangent is negative in the second and fourth quadrant. So if we can say for second quadrant and for fourth quadrant. Right. Now for second quadrant we have pi minus pi by 4. So we will get 1 minus 1 by 4, 3 pi by 4. And for the fourth quadrant we have 2 pi minus pi by 4, right? So we have 2 minus 1 by 4, 7 pi by 4. So we have these two values, right? But as we can see, the range of alpha is that lies between minus pi and plus pi. So it means we need to add 2 pi and subtract 2 pi in these angles as well, right? So let me add 2 pi first. Adding 2 pi, we will get 2 more angles, and subtracting 2 pi, we will get 2 more angles. Okay, so in 3 by 4, add 2, we have 11 pi by 4. Now adding 2 pi in 7 pi by 4, 7 by 4 adding 2 is 15 pi by 4. And now subtracting 2 pi. From 3 by 4 subtracting 2 is minus 5 by 4 pi. And from 7 by 4 subtracting 2 is minus pi by 4. Okay, now we have 6 values for alpha. Let me write down all the values. So the first is 3 pi by 4, 7 pi by 4, 11 pi by 4, 15 pi by 4, minus 5 pi by 4, and minus pi by 4. Okay, now let's see which value lies in the domain. The domain, sorry, the range of the alpha, that is between minus pi to plus pi. Okay, So alpha lies between minus pi to plus pi. It means minus 1 pi to plus 1 pi, between minus 1 and plus 1. So we have 3 by 4 is 0.75. This lies. 7 by 4 is more now. 11 by 4 is more now. 15 by 4 is 3. No. Minus 5 divides 4 is, no, it's more. And minus 1 divides 4 is, yes. So these two values only lies in the given range of alpha. So the answer we have alpha is either 3 pi by 4 or minus pi by 4. So these two values of alpha lies within the given range. Now for part B, in the first part, show that this equals to 2 secant theta. So we need to take the left hand side first, and we can take the LCM from on the left hand side, and the LCM would be cos theta into 1 minus sine theta, right? Okay, and in the numerator we already have 1 minus sine theta. We just multiply with cos theta, so it would be cos square theta, plus we have cos theta multiplying with 1 minus sine theta whole square. It would be 1 square plus sine square theta minus 2 sine theta, right? So this would be equals to cos square theta plus sine square theta is 1, and 1 plus 1 is 2. So 2 minus 2 sine theta over cos theta into 1 minus sine theta. Okay, so from the numerator we can take 2 common, and we are left with 1 minus sine theta. The denominator we have cos theta into 1 minus sine theta. So now from the numerator and the denominator we can cancel the like factors, 1 minus sine theta, and we are left with 2 over cos theta. And this is 2, and 1 by cos is secant theta. So this is equals to our right hand side. So we have proved that the left hand side equals to right hand side. Okay. Now for the second part, hence solve the equation for phi's between 0 to 180 degree. So as you can see, this equation is exactly, this question is exactly the same as the first one. So just in terms of theta, they are using 3 phi, right? So it means cos 3 phi over 1 minus sine 3 phi plus 1 minus sine 3 phi over cos 3 phi. This answer is 2 sine theta, and theta is 3 phi. So secant 3 phi is equals to 4. Right. So in this question, I would like to replace theta equals to 3 phi. Right. So we can say 2 secant of theta equals to 4. Right. And from here, secant theta is 4 by 2, and that is equals to 2. And secant is basically 1 by cos. And what is cos theta? Cos theta is 1 by 2. Right. Okay. Now cos is positive. Now let's see in which quadrant the cos is positive. Okay. So in the first, all trigonometric ratios are positive. Sine is positive. Tan is positive. And cos is positive. Okay, and the rule we have theta, we have 180 minus theta, 180 plus theta, and 360 minus theta. Right. So cos is positive in the first and in the fourth quadrant. Okay, so we can find the value of theta, and then in the first and the fourth quadrant, obviously. So theta is cos inverse of 1 by 2 in terms of degree. So first we need to convert our calculator in degree mod. Okay, so cos inverse of 1 by 2 is 60 degrees. So theta is 60. Okay, now we need to find in the first quadrant and in the fourth quadrant. Okay, so for first quadrant and for the fourth quadrant. For first we have just theta, this is equals to 60 degree. And for the fourth we have 360 minus 60, this is 300 degrees, right? And as we know, the range is between 0 to 180, so we just need to add 2 pi, or we can say just add 360, not subtracting 360, because it is not between minus pi to plus pi. If it is between minus 180 to plus 180, then we add 2 pi and subtract 2 pi, or add 360 and subtract 360. So in this case we just need to add 360. And let's see what are the two answers. So we have 360 plus 60, 420. And for the second, 300 plus 360 is 660. So the values of theta are 60, 300, 420 and 660. Okay. And we know that theta is equals to 3 phi, right? And what is the value for phi? Phi must be equals to theta over 3, right? So we can find the value of phi by dividing all the thetas with 3, right? So 60 divides 3 is 20 degree. 300 divides 3 is 100 degree. 420 divides 3 is 140 degree. 660 divides 3 is 220 degree. 220, sorry. Okay, now we need to find the value of phi that lies within the given range from 0 to 180. So this lie, this lie, this lie, this is more than 180, right? So the only answer is phi is equals to either 20 degrees or 100 degree or 140 degrees, right? Now for question number 11, the normal to the curve at a point where x is equals to 2 meet the y-axis at point P. Find the coordinates of point P. Okay, so we have given the curve and we need to find the equation of normal of this curve. Okay, so the equation of normal is equation of normal is basically y minus y naught is equals to m into x minus x naught. X naught and y naught is a point and m is the slope, or we can say the gradient, right? And how can you find the gradient of normal? So basically we need to find the gradient of tangent is basically equals to minus 1 over gradient of normal. We need to find the gradient of tangent and its negative reciprocal would be equals to gradient of normal. And x naught and y naught is the point. So x value is 2. We can substitute that x value into the curve to get the y value. We will get the point. So first we can find the gradient of tangent. Gradient of tangent is basically the derivative of this curve at the point x is equals to 2, right? So let's do it. So we can apply the quotient rule here because we have in terms of division. So we need to take the square of the denominator. First we have a denominator and then the derivative of the numerator is 1 divides x square plus 2, and this is 2x minus ln of x square plus 2, and the derivative of this term is just 2. Okay, now let me find its gradient at x is equals to 2. So at x is equals to 2, dy over dx will be 2 times 2 minus 3 into 2 times 2 over 2 square plus 2 minus ln of 2 square plus 2 into 2, and it is going to divide with 2 times 2 and then negative 3 whole square, right? So we have 2 times 2, 4. 4 minus 3 is 1, and this is just 1. So 2 times 2 is 4, and we are going to divide it with 4 plus 2 is 6. So this is 2 by 3. This is equals, let me write it down here, 2 by 3, and minus, we have 2 ln 2 square is 4 plus 2 is 6. And we have 2 times 2 is 4, 4 minus 3 is 1, and 1 square is 1. We have just this derivative. This is a gradient of tangent. Now to find the gradient of normal, what we need to do is gradient of normal is basically equals to negative of its reciprocal. So negative 1 divides 2 by 3 minus ln 6. Or we can say minus 3 is at the top over 2 minus 3 ln 6. This is a gradient, right? Okay, so we got the gradient of the normal. Now we need the point x0 and y0. Since we have the function y is equals to ln x square plus 2 over 2x minus 3. So we have the point x is equals to 2. We can find y value at 2 ln. We have 2 square is 4. 4 plus 2 is 6 over 4 minus 1 is 1. So we have the point x0, y0. x0 and the y0 point we have is 2 and ln 6. Now we have a point and we have the gradient as well. Now let me substitute into the equation of normal, that is y minus y0 equals to m into x minus x0. Y minus y0 is ln 6 over x minus x0 is 2 is equals to the gradient, that is negative 3 over 2 minus 3 ln 6. So this is the equation of normal. Okay, so in the question, as you can see, the normal to the curve at a point where x is equals to 2 meets the y-axis. So since it meets the y-axis, so means when the point meets the y-axis, the x value must be equals to 0. Right? So we can substitute x is equals to 0 to get the value for y, and we will get that point, right? So now x is equals to 0. We have y minus ln 6 over minus 2, and this is equals to minus 3 over 2 minus, oh, I did a mistake in this part. So this is 2 by 3 minus 2 ln 6. We have 2 as well. So we have times by 2. So 2 times 3 would be 6. So this would be 6. Right. Okay, so we have 6 ln 6. 6 ln 6. Let me solve for y, because the x is equals to 0. So from here, y minus ln 6 is equals to positive 6 over 2 minus 6 ln 6. And y would be equals to ln 6 plus 6 over 2 minus 6 ln 6. So we have ln 6 times minus 6, add 2, 6 divides answer, and then plus ln 6. We have 1.10. So the y value is 1.11. So the point P, the coordinate for the point P is x, y. Here the x value is 0 and the y is 1.11. Right? So this is the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.